Hi, my name is Alicia. I'll be your guide for Unit 10, Alternating Current Circuits and Electromagnetic Waves. AC circuit. An AC circuit consists of a combination of circuit elements and an AC generator or source. The output of an AC generator is sinusoidal and varies with time according to the following equation. Resisted in an AC circuit. Consider a circuit consisting of an AC source and a resistor. The graph shows the current through the voltage across the resistor. The current and the voltage reach their maximum values at the same time. The current and the voltage are said to be in phase. More about resistors in an AC circuit. The direction of the current has no effect on the behavior of the resistor. The rate at which electrical energy is dissipated is the current is given by following equation. RMS current and voltage. The RMS current is the direct current that would dissipate the same amount of energy in a resistor as is actually dissipated by the AC current. Equation is given below. Alternating voltages can also be discussed in the terms of RMS value. Equation is given below. Ohm's law in an AC circuit. RMS values will be used when discussing AC currents and voltages. AC ammeters and voltmeters are designed to read RMS values. Many of the equations will be in the same form as in DC circuits. Ohm's law for a resistor R in an AC circuit is minus delta Vrms equals to Irms R also applies to the maximum values of V and I. Capacitors in an AC circuit. Consider a circuit containing a capacitor and an AC source. The current starts out at a large value and charges the plates of the capacitor. There is initially no resistance to hinder the flow of the current while the plates are not charged. As the charge on the plates increases, the voltage across the plates increases and current flowing in the circuit decreases. More about capacitors in an AC circuit. The current reverses direction. The voltage across the plates decreases as the plates lose the charge they had accumulated. The voltage across the capacitor lags behind the current by 90 degrees. Capacitive reactance and Ohm's law. The impeding effect of a capacitor on the current in an AC circuit is called the capacitive reactance and is given by the formula below. Inductors in an AC circuit. Consider an AC circuit with a source and an inductor. The current in the circuit is impeded by the back EMF of the inductor. The voltage across the inductor always leads the current by 90 degrees. Inductive reactance and Ohm's law. The effective resistance of a coil in an AC circuit is called its inductive reactance and is given by equation below. The RLC series circuit. The resistor, inductor and capacitor can be combined in a circuit. The current in the same circuit is same at any time and varies sinusoidally with time. Current and voltage relationships in an RLC circuit. The instantaneous voltage across the resistor is in phase with the current. The instantaneous voltage across the inductor leads the current by 90 degrees. The instantaneous voltage across the capacitor lags the current by 90 degrees. Phasor diagrams. To account for the different phases of the voltage drops, vector techniques are used. Represent the voltage across each element as a rotating vector called a phasor. The diagram is called a phasor diagram. Phasor diagram for RLC series circuit. The voltage across the resistor is on the plus x-axis since it is in phase with the current. The voltage across the inductor is on the plus y since it leads the current by 90 degrees. The voltage across the capacitor is on the minus y axis since it lags behind the current by 90 degrees. Phasor diagram continued. The phasors are added as vectors to account for the phase differences in voltages. Delta VL and delta VC are on same line and so the net Y component is delta VL minus delta VC. From the phasor diagram, the voltages are not in phase, so they cannot simply be added to get the voltage across a combination of the elements or the voltage source. Equation is given below. Impedance of a circuit. The impedance Z can also be represented in the phasor diagram. Summary of circuit elements, impedance and phase angles are given below. Power in an AC circuit. No power losses are associated with capacitors and pure conductors in an AC circuit. In a capacitor, during one half of a cycle, energy is stored, and during the other half, the energy is returned to the circuit. In an inductor, the source does work against the back EMF of the inductor and energy is stored in the inductor. But when the current begins to decrease in the circuit, the energy is returned to the circuit. Power in an AC circuit continues. The average power delivered by the generator is converted to internal energy is the resistor. Phase shifts can be used to maximize power outputs. Resonance in an AC circuit. Resonance occurs at frequency F where the current has its maximum value. To achieve the maximum current, the impedance must have its minimum value. Equation is given below. Hi, my name is Alicia. With this, you complete Unit 10 of Electrician Trade. Thank you.